In this video we will start a new topic, that is friction. This is very important for boards as well as for your entrance. So friction generally, it means is a tendency to oppose relative motion. Suppose for example there is a huge block, wooden block, and you are trying to push it. So the force that you are applying on the block, that is the applied force, and suppose the block is not moving due to what? Due to some opposite force. What is that opposite force? That is the friction. Suppose for example there is a car and the car is moving this side with the force F, that is the applied force, and at the same time the wheels of the car that will face some frictional force from the surface of the road, and that frictional force will be in opposite direction. So depending upon whether the object is in motion or rest, friction is basically of two types. One is static friction, one is kinetic friction. So static friction means, here we will discuss first about static friction. Suppose just now I gave you the example, there is a block suppose, and you are applying some force on the block in this direction F, okay. The block is not moving, so that means the surface, suppose this is a surface, this surface is applying an opposing force on the block, and the direction of the opposing force is this side, which is the frictional force. And until and unless this object starts moving, this frictional force will be called static friction. But the other example that I gave you, the car, when the car is moving in this direction, then the car is in motion already, then also there is some friction in the opposite direction. That friction is called kinetic friction. So the friction which is related to an object which is at rest, that is static. As soon as the object starts moving, then also there will be frictional force, and that frictional force or that friction will be of kinetic type. Alright, so I have just written here static friction means related to rest, kinetic friction related to motion. Now we will discuss about static friction. So this static friction, it is a variable force, we can say. Why it is a variable? Again the same example I am giving you. There is a block, okay, it's drawn here only. There is a block suppose, and this block, how much force we are applying? Fa. Fa means it is the applied force. In which direction? In this direction. I am putting some numerical value on it. Suppose the value of this Fa is 10 Newton. So how much force you are applying? 10 Newton. But the object is not moving. So that means certainly the frictional force is also how much? 10 Newton. So this 10 Newton is cancelling this 10 Newton, as a result the object is not moving. Now again instead of 10 Newton, now you are applying a force here in the same direction which is of 15 Newton. Then also the object is not moving. So how much is the value of frictional force then? In opposite side it should be 15. That is why this 15 should cancel this 15, and finally the object will not move. So can we say here, depending upon the applied force, see the frictional force is changing. When the applied force is 10, frictional force is 10. When the applied force is 15, frictional force is 15. Until and unless the object starts moving, frictional force is changing its value. So that is why I have written here that this static friction is a variable force which changes according to the applied force. Okay, and the value of this static friction, it lies between 0 to limiting value, F limiting. Limiting means I will tell you about it, but the static friction, as I told, it is a variable one. It changes. So within how much range it changes? Within 0 to limiting. Now what is limiting thing? What is limiting force? Okay. Again this block, first I have applied a force of 10 Newton. block is not moving. What is the frictional force? 10 Newton. Next I am applying a force of 15 Newton. Block is not moving. What is the frictional force? This side 15 Newton. Next I have applied a force of suppose 16 Newton, 1 Newton more than the previous. Then the block just starts to move, just starts. Okay, so if the block just starts to move, can we say now the static friction will convert to kinetic friction just after this value? So this is called the limiting value. Limiting, where the static friction just beyond this limiting value, static friction converts to kinetic friction, because 16 Newton when I am applying, the object just starts to move. So that means once I cross 16, the object will completely move. Object will start moving. So now static friction will be converted to kinetic friction, and the limiting value means 16. This is this value, F limiting. So F limiting means this is the maximum value of static friction. So that is why I said that static friction, it lies between 0 to limiting value. Limiting means it is the maximum value of static friction. So I hope it is clear. Then another thing I have written, it is self-adjusting. These are some nature of static friction. One nature I said it is variable. One nature I said it lies between this. Another one is self-adjusting. Obviously it is self-adjusting because just now I said that if 10 Newton force is applied, the frictional force becomes 10. When 15 is applied, frictional force becomes 15. So it is adjusting itself. So that is why frictional force or friction, it is a static friction, it is a self-adjusting force, or it is self-adjusting in nature. Now for static friction, okay, this point I have written here, maximum value of static friction is the limiting friction. Already I told about it. Okay, then this is the formula for relative friction, because remember that static friction Fs, it does not have you can say fixed formula. Why it does not have a fixed formula? Because static friction itself is not a fixed value, it is changing, it has a range like this. So it is changing, that is why it does not have a fixed formula. But yes, limiting friction, it has a fixed formula, and that formula is this one. F limiting equals to mu s into n. Mu s is a constant value. It depends on the type of surface, on which surface the object is kept, like on different factors. So mu s is a constant. We call it coefficient of static or limiting friction. N means it is the normal reaction. Normal reaction means if this is the block on which the frictional force is applied. So suppose I am just drawing it here. This is the box. So this box, it will apply its weight in which direction? In downward direction. W is equal to mg. We know this one, in class 9 you got. Weight equals to m into g. M is the mass of the object, g is acceleration due to gravity. So when this object is kept on this surface, the weight is downward. At the same time, the surface is applying a force on the object which is in upward direction. We call it normal reaction, and this normal reaction is N. And remember that in most of the cases, when the object is kept on a surface, then this normal reaction becomes equal to the weight of the object. Okay, so in this formula, in place of N, what we can substitute? Mg, provided the object remains on a horizontal plane. If the plane is like this, horizontal plane, if the object is kept on this horizontal plane, then only its weight, which is in downward direction, W, which is mg, that will be equal to normal reaction N. Okay, there may be cases where W may not be equal to N, but that one we will discuss later on. Now you just remember that for this type of cases, when the object is horizontally kept on a surface, then W equals to N. Okay, so this is about static friction. In next video we will discuss about kinetic friction. Thank you.